Okay, now as he speaks to us on data structures and algorithm, focusing on stacks and... Welcome, sir.
Yeah, thank you. Good evening. Can you hear me?
Yes, I can hear you now.
Okay, good. So just let me know when we are good to go.
Okay. Okay, we are good now. That was why I had to bring you up on stage, as I would say.
Okay. Thank you so much, David. Thank you.
Okay, so thank you, sir.
I'm going to just share my screen. Let me know when you can see my screen.
I can see your screen now.
All right. So I'm using a Jupyter notebook today. So okay. I want to create a new file for this. So it's stacks and queues, right? Am I correct?
Yes, sir.
Okay. Stacks and queues. All right. So I hope is any of us not familiar with Jupyter Notebook?
I don't know for others, but I can manage because all the time I work with VS Code or PyCharm. So
Okay, so the reason why I'm using Jupyter Notebook is because I need to be able to split pieces of the code and run them independently and just work on like that. So that's why. All right, so first, all right, so this is heading stacks. These are just comments, stacks and queues. And we have sorry, I'm using a keyboard. Show my keyboard here. So just a minute, let me change my keyboard to US. Good. Okay. So we have stacks and stacks. This class is going to be very short, right? Because these topics are very, very basic. So first, we know what data structures are, right? Let me not just assume.
We do, sir. Some of us knows that I don't know for every other person, but yes, we should.
Okay, so basically, data structures are just a way for us to structure our data in a computer, right? And then there are myriads of ways you can structure your data. And each programming language comes with some data types, right? Which is gotten from a data structure. So data structure is like the blueprints of how you create a data type. And as such, you don't see the code that creates the data structure that you use, but then you just use that type. For example, we have number as a data type, we have list, we have arrays, we have dictionaries, and rest of them. And these are designed to actually work differently. And data structures comes in two forms. It comes with the data type and then operations that can happen to the data type. A typical example is object-oriented programming, right? You have the class declaration, which is the blueprint of the object, and then you have the object instantiation when you instantiate the object, right? So bringing the class to life, that is the object. Bringing the data structure to life, that is the data type. So that said, we are talking about two really, really basic data structures here today. Stacks and queues. Stacks are books on a table, right? Stacks are books on a table. Queues are just people lining up to withdraw at an ATM ATM gallery. All right, so this is what stacks and queues are basically. And then as such, for stacks, you are lining up books on a table, right? And how it works is that you keep putting up books book one, book two. The first person to get on the queue is the first person to go out. So we'll call this FIFO. First in, first out. Last in, first out.
Excuse me, sir.
Yeah.
Please, we cannot see the screen you're writing on.
Oh. Let me confirm. Okay. Sorry. When I created the project, it opened up a new tab for me. Sorry. I thought I was sharing the real tab. Okay. Thank God it's woke up. I think you can see that now.
I can see it now. Yes, sir. Thank you.
Yes, I can see it.
All right, good. Thank you. So, stacks are books on a table, like I said. The last item you placed in is the first item to go out because it's at the top. It's just like stacking up plates on top of each other. The last one to go in is the first one that goes out. And people going into a queue, right? That is queues. And the idea is the first person to come in is the first person to go out. That's why I said queues are like people lining up to withdraw at an ATM gallery. You that got there first will be the first to withdraw, right? And so on and so forth. So we get into how to create this and see how it looks like in our code. But before that, what is the purpose of this? We have other data types to store things contiguously in the memory. Like we have lists in Python to store a collection of items, right? But now we want to store a collection of items. But instead of as a list, we want to use a stack or a queue. What is the pro and cons of using these? Why are these better? Which one is better? And in what scenario would one be better than the other? Right? Now, we already have list or array created for us, right? But then why are we creating stack, a new one? Or why are we creating queue, a new one? Or why are we creating linked list, a new one? Or a single linked list, a double linked list, or a circular linked list? Or whatever, linear stack, circular stack, or queue, and all of that. Why are we doing all of that? Why is it better? Why is one better than the other? Now, you will learn about that when you start talking about algorithms and the big O notation, right? Now, algorithms are just ways to actually measure the efficiency of a software or a program, or in this case, your code, or your data structure, or your algorithm, or whatever it is you are writing. So when we start measuring, that's where pros and cons come out from. For example, let's say we have created this. If I want to search for an item, right? Which one is easy for me to actually search for if I store the items this way? How will it be easier for me to search, right? If I'm using an array, right, or a list in Python. Now, Python list is not an array, but it has all the features of an array. So we automatically just call it an array, right? But it's not an array, it's a list. Python still has a library or a module for array that does array really well. And then if you are using pandas, you find an even better array in pandas or NumPy. So that's it. We have an array. If we have items stored in an array and want to access the last item in the array, we'll have to go through the whole array, the whole list, right? Sequentially, so we'll get to the last, right? Which makes, okay, let me write this first. First in, first out. Okay, now that we have written this, so let's say we have an array of 1, 2, 3, 4, 5, 6 items, and I want to pick this 6th item. This array is of 6. Now, the big O notation for this is O, big capital 0 of n. Now, this is how long I will have to work to get to any of the value I need to get to, right? Now, if this increases tomorrow, right, the time I'll have to go through to actually get any of the value is, it gets increased exponentially, right? So that is this. But then we have stacks, right? And for stacks, on the other hand, we have items 1, 2, 3, 4, 5, 6 as well, right? But if I want to access something with this, right, it is O of 1, meaning the time it will take me to actually access an item is constant, because I'm not going through everything. I'm only picking one thing at a time. I don't have access to everything. I only have access to just one thing, which is either for stacks, right? That is the last thing that entered. That is what I have access to, right? And then this last thing has a pointer pointing to the next last thing. If I delete the value 1 from this array, right, what it would do next is start shifting everything one by one, right? One by one, this becomes index 0, this becomes index 1, this becomes replacing each of the value. It takes a longer time to process. But then if I remove 1 from here, right, this is the first and this is the last. and I only have access to just this one, what it's going to do for me instead is, okay, since this one is out, I'm going to make this one the first. This remains the last. This has a pointer to point to this one. This has points to this. This has points to this. This has points to this. And this has pointed to nothing. So I can just access just this value and go. And a good place you find this is your browser. When you click the back arrow to go back to your previous page or the next page you went to, right? You can't go back 2 pages at the same time. You can only go back 1 page, right? And you click the arrow again, it goes back to the previous one because it just popped one out, which is the last one that got in. That is stack. Okay? That is stack for your browser navigation to move back the previous place you went through. Do we understand it just now?
I'm understanding you, sir. Thank you.
All right. So queues, on the other hand, is exactly like stack. The only difference is that for stacks, we have access to only the last thing that was added, while for queues, we have access only to the first thing that was added. When the first thing goes out, we'll pick the next. That one goes out, we'll pick the next. And we'll pick the next, and 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 the next. Are we good? Is that clear?
I'm good from here. Yes.
Yes.
All right, so let's get coding there. I've forgotten this again. Sorry, let me check my shortcuts again. Shift new. Okay. So I have this now. Now I can start writing. Now, first thing I want to do is I want to create the stacks, right? The stacks. That's what I want to create, the stacks data structure. Now, first, there are 2 ways to actually create this, right? I can create the stack data structure from an abstract data structure or a base data structure, which is either an array or I use a linked list, either a singly linked list or a doubly linked list or whatever. And then the best one is using linked list, right? It's more efficient, but then we are going to create it using an array, right? Which is easier because we already know an array. Have we learned about linked list before?
Yes.
And we have good knowledge of linked list, right?
Yes, sir.
So what is a linked list? What is
Hello,
a linked
sir.
list?
It's just I don't know how to really define it, but it's just like a collection of data joined together
Okay.
with, by a pointer. It's like, just a collection of data. Each one
By a
links
pointer.
to each one. Yes, each one links to each one.
Where one data has a node to the
A
next,
node
right?
to the next, yes. A pointer to the next.
Yes. And that is it. And that is exactly how the stacks data structure actually work as well. But then it's only a bit, let's say, different. But then it's not totally different. So that's why that is better. But then it's easier to implement using an array. But then better with a linked list because a linked list has to access an item on a linked list, it has an O of 1, and that's what we also want for this as well. So let's create our class. and call this stack. Now, for this, we want to initialize and then self. And right, so we have this. Now for this, what we now need to have below here is just the value, right? So self dot value equals value. Self value is equal to none, right? It doesn't have any value. And then we have the next, self dot next, which is the next value or next data, is equal to none as well, right? And then it does four things. This is everything about Stack, actually, right? This is everything about Stack. It's created already, but then it does four things. So you can push data to a stack, push, self, and then you give a value you want to push to it. And let's call this data, so it doesn't conflict. And pass. And then it can also pop, which is remove an item from and then it can also pick, which is find an item, right? In and then also it can as well, what's the last one again? Push up, pick, and then is empty. Check if it's actually empty as well. So yeah, let's add things to this guy. Right. So to add things here, what we actually need to do, this should be, yeah. The values in our stack should be a list, right? And then the next is empty. So now to add things here, we want to self dot values dot append, right, our data, which is what we got from here, and we'll append a data to this. We also want to get the position, right, and know where the length is, right? So who is messaging me? All right, so what do we do here? Yeah, so self dot next equals um, the length of self dot values, right, plus 1. Yeah, so we have this. Now, before we can add um, anything to this, I think this still works. This still works, yeah. Still works. Yeah, this is not linked list, so it still works, yes. So we get this, and then to remove an item from it, we only want to do self dot values dot pop, and yeah, that's that. And then to pick, we want to do self dot values um, yeah, -1. Let's return that back. And here, if self dot values if the length of the values is less than 1, we want to return stack is empty. Else, we want to return false. I don't say false and true here. True. So we return the true Boolean value and false Boolean value. And here we have this created successfully. Yeah, now I can run this. Now that is run, I can now do my tests, right? So my stack is equal to stack. I have my stack now. I can, my stack dot push. Let's push Moses there. And let's push Dave. Let's also push Christiana. And let's put Chidera there. So we have 4 things there now. If I do okay, here We added to our stack. Let's just run this. I've run that part of the code, and let's now print my stack dot pick and run this part. I get Chidera because that was the last item added to our first thing here. Let's remove Moses from there and put Moses here, right? Let's run this as well as this. Now, Moses is the last item. That is what we get each time we run pick to look at our stack. This is the only thing we can see, right? So if we want to get the next person, then how can we get the next person? For what we have here, how can we get the next person? Anybody, how can we get the next person?
Okay, anybody in the house to speak?
Yes, yes.
Okay, House is asking a question. So if you have an answer, just speak.
I have a bug. Okay, let's keep that pending. Let's move on. We can add item. We can, let's check Bob. My stack dot Bob item, and let's run that, and then let's do my stack dot pick again, and the last person here should now be Chidera. So we get Chidera, and if we check if it's empty, my stack dot is empty. We get false. It's not empty. If we comment this out and run this part of the code and come here and run this again, we'll get true because this never existed anymore. Right? Never existed anymore. That's why it's now empty. So let's return it back. Now, this is our stack.
Hello, sir.
Yes.
You asked a question before.
Yes.
So,
Yes.
Is it possible to pass an argument inside the function to pick?
Inside a pick function, right?
I can say as you have explained before.
Yes.
For example, if we say pick only, it will just only pick the last item or the last person name. I don't know.
Now you are right.
Okay,
the answer I have given this before, right? You cannot. I intentionally put this here and I never made use of it. when you are creating the same structure with a linked list, you will need this for creating the nodes of the linked list, right? So I'm taking this out. It's not needed here. You can't get the previous value because this is a stack. You only have access to the last item added
Last
to
item.
the stack. You get the jig now.
Okay. Thank you.
All right, so that is it. And yes, now we can create for queues. For queues, it's still fairly same thing, right? Class queue. Okay, so class queue. Is that a spec queue? Looking different.
Yes.
All right, so self dot queue equals an array as well. No, not self dot queue. Sorry. df underscore init underscore self. Yeah. So that's what we have there. And this one has something different. Now we have NQ. That is what it's called. Self and then data. And then we have the queue. The queue. Self and let's make it pass. And we also have peak. Sorry. Peak. And we also have it's empty. Now, to add someone to queue, you enqueue, right? To remove someone or something from the queue, you dequeue the queue, right? I don't know if that makes sense. Now,
Yes,
to add
yes,
to the
yes.
queue, you use the queue. To remove from the queue, you enqueue, right? Sorry, to add enqueue, to remove the queue. While for the stack, to add is push, while to remove is pop. Right. That said, now let's add to it. To add to this, all we have to do is self dot queue dot append data. Yeah. That is the only thing we are doing there. Then to the queue, we are doing self dot data, self dot queue dot pop, and this time we are popping the first item on the queue, 0. And then to pick, we are return self dot queue 0. Yeah, that's the first person that entered there. and then it empties same code we had here. Same thing we have here. If the length is less than the Q, right? Don't true or false. Let us do that. If length of self dot Q is less than 1, right? Return true, else return false. So that's done. And run this and then do our tests. So my Q, I've got my name. Just doing this real quick. So the Q is created, and now let's add to the Q my Q dot NQ, and let's add two um, 4, 6, 7, 9. We have that. They have been added. Okay. Who knows why we have this error? I remember I intentionally left it. There's an error here. There's an error with the NQ. Who can spot that out?
The error is in the append, self.q.append.
All
So
right.
you spelled your append wrong.
Thank you. Thank you for that. So let's run this again. And let's run this again. Sorry, I have to run this instantiation again and then this. And that is done. Right. So now we can do my Q dot speak. And we get 2. Because that was the first item that was added. Right? And when I do my Q dot DQ, and then my Q dot speak again, I get 4 because now 2 is out. I don't have access to everything on here, right? But if I call my Q here, I get the class, right? If I try to access everything in the queue, right, I get the class instead. But I can still do my Q dot Q, yeah, and I get everything inside the queue, which should not be possible outside of our class. So we have to find a way to actually protect this. But then that's another topic for another day. So we have this, and we can check if my queue, right, dot is empty. And yes, it's not empty because it has values. If I take out all the values it has, like so, and then run this again, I get, oh, sorry, I didn't run this part. And let's run this again. What happened? Why is it false twice? let's say that one. Yeah, add anything to the queue. There is something. Oh, let's do this. Okay. So it's empty now. Yeah, out of range. Out of range. And here we get true now is empty. Now, who knows how we can prevent this error from happening?
Using
Who
try
knows how we can...
catch.
Sorry?
Sorry, using try and accept or raise
Yeah.
exception.
Yeah, we can do that. What other way can we do? What other thing can we do here? All right, we can just do this, right? If self dot is empty, right? Then return Q is empty. Else return the Q. And let's run that. And let's run this again. Out of range. So yeah, Q is empty. That is a check here, right? And this is our exception. Handling our exception, but without using the try and accept low. More low level. What else is there to touch? Again? All right, there's nothing here else left to touch. Do we understand this? Do we understand this?
Yes.
All right, so the key takeout from this is that the implementation, right, is based off a purpose. Why you implement it is based off of a purpose, right? If, for example, you are, okay, a good example of the queue, I gave an example of the stack already, right? A good example of the queue, the stack is just your browser going back and forward. Well, a good example of the queue is this, okay? Now, for the queue, take for example, you are building a file manager that copies file, right? Synchronously. If you copy 100 files, right? The first one you selected, and the second one and the third one, it has to go sequentially. So it copies the first one first, right? Takes it out of the queue, takes the next one, copy it, takes it out of the queue, and then the next, and 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 the next. Or you want to send a mail to, say, 1,000 persons, right? You put your emails 1, 2, 3 to 1,000, and then you start sending the mail one by one. He sends this one, takes it off, and then sends the next one, takes it off, send the next one till it's done, and then the whole list is empty. Or the whole queue of mails are empty. That is just another example of where queues, data structure are important, and how to manage or why you should create such a data you are creating for such a purpose, something like that. So yeah, any questions? I think that's everything for these two topics. Any questions?
Hello.
Yes, yes.
Okay. Sorry. Please. When you started, before you started coding, you said there are two implementations to stack and queue. Is either you use an arrow or
I
you
use a
use
link.
linked list, either double linked list
Yes.
or single linked list. So, from your own perspective, which is faster and which is actually faster to implement? Thank you.
By implementation, right? If you understand arrays and you don't understand linked lists, arrays is faster to implement. If you understand linked lists and you don't understand arrays, linked list is faster to implement for you. So it depends on you. And then I think your question is not about how you can write it or which, but rather which is better, right? When you build.
Yes, because I know with linked list it allocates the memory during runtime. But when you're using an
Yes.
array, it creates like I think linked list is dynamic.
Size.
Yes.
A linked list is more dynamic, right? In terms of it works exactly as the idea of the stack or the queue, right? Where you have nodes and then it's pointing to the next, and you can just get to the next, right? Unlike we getting all of the values. For a linked list, we won't be able to get all of the values just like that. We only have access to the memory of the next value for a linked list, which solves one of that problem that we have with an array. And then another thing is that when accessing an item in the linked list, it is faster because it has an O of one big O. It has big O of one, right? A constant time to actually search, right, or find an item. But then an array has an O of n to search for an item, except probably you are using a binary search, right, which is a different algorithm rather than using linear search, right, which can actually still cut it down the time a bit. So it depends on whatever you are doing, right? But right now, you understand basic concepts. You can add, you can remove, right? So what you are, for a stack or a linked list, you are adding and you are removing, right? When you are creating with a linked list, the only idea you need to have as an extra is that you are swapping, right? I have this value as the first value that was entered, right, for a queue. And this is the first person, right? Point to the second person. When the second person is coming, I have to add a link to the next person, right? And then also have a link to the second person that was added. The next person is none, right? Which is the last person is none. And the last person is pointing to none, while the first person is pointing to the second person that was added. I'll have three. The first person is pointing to the second is pointing to the third, and then the third is pointing to none, right? For other languages, it's most likely to point to null, N-U-L-L, instead of none. Python has none. Other language has null and also have none as well. I think Java has both. That's a crazy language anyways. So that aside, there's something I wanted to say again. Now, when you remove an item from a queue, right, you are removing the first item, right? As you're removing the first item, right, you are only swapping one value, right? The first item is the head, right? Or the first item or the top item. Now, you are taking the title of the head from the first that hasn't popped out of the queue and give it to the next, which is the second item. Make that the first. Why the last remains the last? And then the third becomes the second, and so on and so forth until you get to the last. That is why an array is bad. But then if you need to be able to index or get each of the value regardless of their position, right, then an array is better. Now, browsers now has the feature where you can actually get each of them, where for your back arrow key, you can just click and hold, and then you see a list of all of the values that all of the pages you have visited going backward, and then you can select which one you want. Even in your file manager as well, you can also have that feature too. Instead of pressing your backspace to go back, you can just click on the drop down and you see every place you've come from, and you can go to a particular one. That is where an array comes in handy, and that is where an array is better. In detecting or assessing, then a linked list is better. Am I clear?
Yes. But there was
Alright,
something I noticed. Like for your DQ, for your
Yeah.
stack, for instance,
Yeah.
now when you pop out the value and remove it from the array, but for the DQ, it did not bring out any value when you did DQ.
Okay. Let me see. For the pop, it won't bring anything value actually. It just removed for the pop of the stack, it just removed the last item, right? While the DQ removed the first item, which is index of 0, right? But then, if you are using a linked list, you are not removing index of 0, you are removing the head and swap the title of the head to the next. Do you understand?
Yes, understood. Yes.
Yeah, that is it. That is it. So I'm not saying all it's just doing, just want to DQ, remove, just remove. We don't have to know who actually access, so we actually conclude that he has removed this. Print out the person before you delete the person. Do you understand me now? Sorry, somebody was calling me. Is it clear now?
Yeah, it's very clear. Thank you.
All right. So, any other questions? I think I have some questions in there.
Yeah. Hello. Good evening. Hello. Hello.
Yeah. Good evening, Brian.
Yeah. Good evening. Thank you very much for this session. My question is, can we specify a size for the queue or the stack, like to give it a maximum size? So where we are checking for is empty. We can also check if the stack is full or the queue is full, something like that. So like give it a size. Okay.
Yes, you can do that. All you have to do is during your initialization, right? You can specify a maximum size, and then before you add to enqueue to the queue, you check if it's full or not. Before you add and return an error. That's just that. But then using an array, right? For other languages like Java or C++, you have to specify the size of your array by default before you go move ahead, right? Which solves that problem. For Python, you have to specify length and then check if the length is full while counting.
Okay.
Right? So that is one. And then two, Um, for language like C++, like so, when you want to increase the size of your array, right, you have to come back to your implementation to increase the size, or dynamically allocate an extra size, or when it's full, there is an overflow and it gets double of the memory. Python has a good memory manager that automatically just increase the size of your in quote array. This is a list, but then in quote array, Python automatically just increase and make the size as small as your data needs.
Okay.
Yes.
All right. So okay.
Something
Go on,
else
sir.
I wanted to add, right? Python is a dynamically typed language, as well as it is statically typed, because it runs on the JIT compiler, right? Not the interpreter. It's not just interpreted. It's a JIT compiler because it runs and then optimizes along the line and then compiles. Now, as such, you can actually program for the compiler the same way you do for C or Java or any of the other languages that are low level or statically typed.
Okay.
This is called a list, right? I can specify it beforehand that, hey, you're going to be holding a list by just adding a colon here and just type list. Python knows that this is going to be a list. That way, it doesn't have to think, okay, is this a list or is it a dictionary or is it a number or what? It doesn't need to check that again. From here, it stops here and moves on and creates a list automatically. Or expect a list. For your function, for example, this function that I'm going to be returning something, right? I can specify what I want to return here as with the arrow here and say, okay, I'm returning a string. If I'm only returning a string, but this time around, I'm either returning a string, my value can be a number inside my queue, can be a string, can be a list or whatever, right? So I can still return a string, or in this case, I can return any. Any. So the program knows beforehand, not start guessing. Now, the process of guessing, your program is taking longer to actually run. This way, you optimize the speed of your program as well. Okay? So yes, that said as well. If I run this program, this is my queues. Let me uncheck all of this. Run this, and then pick. We still have today as the first item that was added. So everything still works fine, right? The queue and this, we now have 4 because we've removed 2 from it, and we can actually get this and say it's false because there are values there. Let's see the values that are there, which are same values here, right? So everything works as is expected. This function should be returning a boolean, a bool, because is that true or false? All these little additions, right? So this is returning none. This is returning none. And this as well is not returning anything. And yeah, that's everything for this. You can optimize this as well, but then you get the idea.
Yes. Thank you very much. So this same logic is going to work for a linked list.
Yes, it's good. This is Python programming, not just for.
No, I mean, for an array, you can specify the size. But for a linked list, you just have to add just pointing. So that was why
you can also specify the size of how many pointing you can get and how many nodes you can have as well. But that is
Okay.
complex.
Yes, that was what I thought. That was why I
You
asked the
can
question.
count the nodes you have, actually,
Okay.
by just traversing backwards as far as you can get to. But then, for the purpose of stacks and queues, you don't need to do that. But there are some specific business logic that are required to do such. Then you'll know how to implement such.
Okay.
Mm-hmm.
All right. So I think that's all. Thank you very much.
All right, thank you.
Hello, sir. Please, you are talking about lists being different from arrays in Python. I don't know. Maybe you should throw more light on that. Because I was actually thinking that Python list is actually arrays in Python. So this is the
Okay,
first time I'm hearing that they're different.
Let me show you something else. Show you this. Just a moment. I want to open up a new tab and show you something. I can't explain it, but I know it. So I want to go to Google. Python list versus array. Right? You see, this is an argument already. So you can see that both lists and arrays are used to store data in Python. Moreover, both data structures allow indexing, slicing, and iterating, which are the core of an array. Both data structures. So there are two different data structures. Should I use list or array in Python? Right? So list can contain elements of different types. Array can contain elements of different types. Variable size nesting is possible. Need to have the same size of the array for nesting. Cannot apply direct arithmetic operations. Can apply direct arithmetic operations. So this is just what you need to know about the two different data types. So Python has both of them actually. Is Python list just an array? Lists are another data structure similar to NumPy arrays. But unlike NumPy arrays, lists are a part of core Python. Lists have a variety of uses. They are used, for example, in various bookkeeping tasks that arise in computer programming. Like arrays, they are sometimes used to store data. So, that is that. I hope that answered the question.
Yeah, it's quite clear.
Yeah,
But
they are not the same.
But I don't know how is it even declared? Sorry, I'm
How they are declared?
Yes. How the array, the list is clear. How the list is declared? Well, how array is declared in Python?
Let me see. I've forgotten how it is declared directly in Python, but let me come back here and see. So there's let's say R equals array, and let's run this. Yeah, array is not defined. There is somewhere you can import array from. I forgot where the import through Google it, import array Python. Okay, just a moment, let me look for it. I've forgotten where it is. Okay, it's just array. So import array, right? And then array. Module object is not callable. Import array. Oh, sorry. It's a module. It's a module, not the actual thing. So because it's a module, I needed to do array. It's an array module, yeah. And run. Array takes at least one given argument, so I can put 1, 2, 3, 4. At most 2, but then 4 were given. Anyways, I've not used this Python's array. I've always used NumPy, not this. That has capital A. So I think it takes, I don't know what it takes. Let me check Google and see. Okay, it takes the type, and then it takes the value you want to give to it. Oh, like a native language, yeah. So the type, if I'm giving it an integer, I specify the type I, and then I go on to start putting everything I want in square brackets here, like so. 1, 2, 3, 4, 5, and that is an array of integers. And then we have let's call it array int, and we have array of let's call it float, but it's not float. It's actually a double data type, and array dot array, and double should be D, I think. And then if I give it 1, 2, 3, 4, 5, it works, but it's supposed to be 1 by default. We'll convert it to 1.0, 2 points, and all of that. So anyhow, I can do R int and index of 3, and I get 4 because 0, 1, 2, 3, that's 4, right? And array double, and let's get index of 1. I get 2.0, but I added 2 here. You see the difference? So yeah, if it's string, you have to make it known or let it know that, okay, I'm giving you strings. But then it's a bit tricky and confusing. Arrays is a big topic. That is why Python created list. I made it simpler. So you can add anything, and then just that I'm not telling the size here, but I could tell the size. So yeah, that is how to implement an array. Yes, that's how to implement an array. Thank you for bringing that up. All right, I think that's all the questions we have.
Yes, sir. Thanks, sir.
Does anyone still have any other question? All right, I take that as a no. So over to you now, Dave. My job here is done. And I hope I did well.
Of course, you did you did amazing here. In fact, I'm looking forward to watching the videos all over again so that I'll really grab all the concepts I missed. And I want to appreciate you for giving us your time out of your busy schedule. I think yesterday you had an interview, and coming back from that, you are still available for us. So on behalf of the community, I want to say a very big thank you to you, and we look forward to meeting you again.
All right, thank you.
All right, sir. So everybody, please unmute your mic for once and say thank you to our guest speaker.
Thank you so much, Mr. Moses. Thank you so much.
Thank you so much for your time.
Thank you.
It was nice one. Thank you, everybody.
Okay, that's beautiful. Thank you, everybody, for that. I'm sure he's seeing your emojis and he's hearing you. Thank you, sir.
Thank you.
Okay, sir. So after now, okay, sir. Thank you very, very much. After now, I'll be dropping a link to your profiles in case some of us here would love to meet you and ask you more questions if they have more. If that's okay by you.
That's totally fine.
Okay, sir. Thank you very much and good night.
All right, good night.
Okay. Okay. Okay, so everybody, I want to thank you for coming out, and I believe we all enjoyed the session, and we all learned a few things from it. So after now, the link to the video will be available. The media team, I believe, they've been recording it, so we'll have a link to the video maybe by tomorrow. So for those who missed, we could go over it again, like myself.